Welcome. Today I'm going to talk to you guys about motion and how you know when something's moving. It's probably one of those topics that I think in physics you're going to say, why do we really even need to talk about this? Because I know when something's moving. It's obvious. Well, I just want to point out a couple of things that you may not have consciously thought of, but that your brain actually does to be able to analyze whether something is moving or not. So we're going to take a look at what that looks like here in video 008 called motion. Hopefully it'll make sense to you here. First, how do I know that something is moving? Couldn't be any easier. It's a simple question, and it really bases itself off of the topics that we had in the last video. And that really, if you look at it, looks something like this. Okay, so here's the ground again, and I've decided that my reference point here is going to be this rock, just like I had it in the last video. And over here, I have decided to go ahead and analyze the motion, and I'm going to do it this way here. Analyze the motion of a toy car. So here's my toy car right there. Right there. Okay, easy enough. Now, obviously, the toy car is sitting on the ground. So how do I know if something is moving? Well, here's the basics, the simplest possible way that I can describe it. If I were to measure, let's say, at the first instant that I see the car, so let's say time equals 0 seconds. So no seconds have elapsed at this point. So it's the moment that I notice that the car is actually there. I see that the car is this far away from my reference point. If I take a look away, let's say I look someplace else for a while, and then I look back at it, I end up seeing that, let's say, at time equals 2 seconds. So now 2 seconds have gone by. Obviously, whenever I do a time measurement, I'm going to give myself more sig figs than this, but you get the idea. Now let's say instead that the car has relocated itself to right here. And something happened that dented the roof, apparently, because that's a pretty terrible car. But it is what it is. It's fine. So what's its new position? Well, its new position is at a distance of this far away from the reference point. So I'm going to draw some dashed lines here so that you can see, you can compare. And we always, as you notice, measure away from a center point. And we'll talk about why we measure away from a center point later on. Whatever point you decide to measure away from, make sure that you stay consistent with it. Anyway, so at time 0 seconds, the first instant I noticed it, it was here. And then 2 seconds later, I noticed it was here. What had to happen during that intervening time, even if I didn't see it, I know that the car ended up moving that far. Would you agree with that? I hope so, because how else would it get from here to there? It had to be able to move through space. And so that's really how I know if something's moved or not. It's pretty straightforward. The difference between these two, you can see right here. If this is the position at time 0 seconds, and this is the position at time 2 seconds, you can see that what I've drawn up here is actually the change in that position. So that the position has changed by that much. And I draw it as an arrow so I can show you that it changed to the right. And you may remember that a right side change, moving to the right, on a number line would be moving in the positive direction. And so we would say this has a sort of a motion in the positive direction. Or if you have other dimensions here, you might say maybe this is east. I don't know. Could be whatever. Or it could be to the right, or it could be something. So you can see it's moved to the right somehow, or it moved in the positive direction, or moved to the east. Any of those would be good, as long as you define it with somebody. So that's pretty easy, right? If instead I saw it move in the other direction, so let's say I have at a later time, I notice that the car ends up here. Usually physicists only draw boxes, so I'm trying to do my best for you guys. So let's use purple. Okay, so now all of a sudden at time 4 seconds, I notice that it is located here, over that way. So you'd see that now all of a sudden it's moved from this position all the way down to this position. Or, if you will, it moved all the way from here all the way over there. And so you can see that there must have been some change in its, it must have moved to be able to get from here to there in 2 seconds. And how much did it move? It moved by this much. And we know that that's in the negative direction because it's to the left. You could also say west here if you wanted to, if that makes you happy. Usually those would be the two types of dimensions that you would use. So easy enough, right? Okay. Now, how do I show that change mathematically? Well, it's again pretty simple, and it's based off of what we talked about in the last video, and that is we use the variables that we talk about with position. So initially, and I'm just going to redraw this here real quick. So there's our rock, here's our car, and then here's our car at a later time. Okay, so we would say that this is its first position. So this is x sub 1. So it's first position. Now if you remember from the last drawing there, what I said was that that was at time 0 seconds. So the moment, the actual instant that I notice where the car is located, that position is x sub 1. The sub just means it's at that first time that I see it. That's all. Anytime you have a subscript, we're talking about something that happens in a specific case or at a specific time. And so in this case, it's the first time I see it. Now, later on, as after 2 seconds have elapsed, I notice that it's here. And so I have x sub 2. So the second time I see it, it's here. That's my second observation of it. And remember that that was at time 2 seconds. Like so. And so its position is now here, all the way over there. And so what must have happened is it must have moved from here to there. And so we say its position has changed by that much. Now, mathematically speaking, we would say that its position changed by x sub 2 minus x sub 1. That's the difference between those two measurements, x sub 2 minus x sub 1. And that will tell us how far it moved, the distance that it moved. Now, we do this a lot in physics, and I have to tell you, I am super lazy. So anytime I'm going to write out x sub 2 minus x sub 1, I'm going to take a shortcut. And don't let this get confusing for you. The shortcut is something I'm going to use often, so it's something you're going to want to pay attention to. And that is, this is equal to, it's the same thing as this symbol right here, delta x. This delta just means the change. So what I'm saying when I say delta x is the change in x. Wouldn't you agree that the change in x is another way of saying x sub 2 minus x sub 1? It's the same thing. But I am lazy, and this is something we do a lot, so I don't want to have to write that out every time. Again, it's so much easier just to write delta x. And then everyone understands that when you see the delta there, what you really mean is a second case minus a first case. It's always going to be some number minus some other number, and it's all the same variables, so they're both x values. So delta x is the change in x. Again, it's a Greek letter. You can kind of see it. I'll draw it out so you can see it here just in case you're curious. The delta looks like a triangle, right? Don't call it a triangle though. The delta became our capital letter D. Can you see how they're related there? So a capital letter D looks very similar to a delta. In fact, the way that I write my last name oftentimes like so, which you can't see on this because my pen can't handle fast motion like that. You can even see it even more that the D and the delta are very closely related. In fact, they come from the same place. Hopefully that makes sense. So whenever you see delta x, you're going to say it's the change in position. Can we use delta with anything else? Absolutely. In fact, the other thing we're going to use it with, and you're going to see very soon, is delta t. So delta t stands for the time in the second case minus the time in the first case. The delta means this minus here of the two cases. Again, just like the delta right there means it. Okay, hopefully that makes sense. Again, it's one of those things that comes up pretty often in here, so we want to make sure that you've got it. The last piece, and this is just a real quick one, and I'm not going to spend a ton of time on it, but physics is all about energy. And so why do we talk about motion? Well, because motion is really energy. In fact, motion is the main form of energy that we're going to talk about in the class. We either have things that are moving or things that could move if you let them go. And those two things are really two different forms of energy. So the first form of energy that we're going to talk about here is kinetic energy. Kinetic means moving, right? So you're moving around. In fact, if you've ever heard the phrase, "Ooh, I had so much sugar, I'm hyper." Hyper is actually short for hyperkinetic. Hyperkinetic means you move around too much. So kinetic, this kinesiology, it all has to do with motion. Those are all from the Greek word for motion. So kinetic energy is the energy of motion. We're going to talk about that quite a bit this unit and next unit and the unit after as well. So get ready for that. Okay, push myself off to the side here. If you have any further questions, of course, first you want to make sure to do your note sheet so that you've got that down, and second, you want to make sure to fill in your interesting question form, and that's where your biggest questions should go, into the interesting question form, so that we can talk about them in class tomorrow. If you have any other questions you don't want to ask publicly, or questions that you think you may want to have answered in more in depth that maybe other people don't need, say specifically how does motion work in calculus, for example. Let's say you're taking calc and you want a preview of how it's going to look when you get to that in your math class. You're welcome to go ahead and ask, and I will try my best to answer that stuff for you. Okay, that's it. If you have any further questions, let me know. Don't forget, you can always email me too. Thanks for watching.